Assalamu alaikum. Following previous lecture, we'll discuss force on a current carrying conductor. A force will be applied on a current carrying conductor placed in a magnetic field. If a current carrying conductor is placed in a magnetic field, a force will be applied on the conductor. We'll determine the force direction now. The force, it is determined by the Fleming left-hand rule. Fleming left-hand rule. The index finger points towards the field direction and the middle finger points towards the current direction, and the thumb fingers will give the direction of the force, will show the direction of the force. Now in this case, the index finger will show the field direction, showing the field direction, and the middle finger shows the current direction, and the thumb points towards into the board. This direction will be the force direction. So force on a current carrying conductor. A force will be applied on a current carrying conductor placed in a magnetic field, because current carrying conductor also create its own magnetic field, and its current carrying conductor's magnetic field interacts with the another magnetic field, and this interaction leads to a force that is applied on the current carrying conductor. Quantifying the force. Experiment shows that force is directly proportional to the current on the conductor. force is directly proportional to the length of the conductor. Force is proportional to sine theta, where theta is equal to angle between field and current. Summarizing these three gives us F proportional to IL sin theta. Removing the proportional sign, we get F is equal to B IL sin theta, where B is magnetic flux density. The unit of B is Tesla. So experiment show that F is directly proportional to current on the conductor, F is directly proportional to the length of the conductor, and F is proportional to sin theta, where theta is equal to angle between field and current. So F is equal to BIL sin theta. F max when theta is equal to 90 degrees, so sin theta is equal to 1. সুতরাং F max is equal to BIL. F minimum is equal to 0 when theta is equal to 0, so sin theta is equal to 0. Now we will define B magnetic flux density. F is equal to BIL sin theta, so B is equal to F divided by IL sin theta, F divided by IL, when sin theta is equal to 1, theta is equal to 90 degree. So magnetic flux density is the force on the conductor per unit current per unit length where conductor positioned at 90 degree to the direction of the force, direction of the magnetic field. B is the force on the conductor per unit current per unit length, where conductor position at 90 degree to the direction of the field. Magnetic flux density 1 Tesla means it would exert 1 Newton force on the conductor per unit length per unit current position at 90 degree to the direction of the field. From this theory, we get another difference between magnetic and electric field. In case of magnetic field, the field direction, the force direction is perpendicular to the field direction. And in case of electric field, the force direction towards the field direction. This is another difference between magnetic and electric field. As far as we have seen that the force on a current carrying conductor can be determined by Fleming left-hand rule. Fleming left-hand rule, where the index fingers point towards the field direction and the middle finger points toward the current direction and the thumb gives the direction of the force. And this force is equal to BIL sin theta, where B is equal to magnetic flux density, I kind on the conductor, L is equal to length of the conductor. L is the length of the conductor. This conductor length. Angle between theta is equal to angle between field direction and the current direction. And F max is equal to BIL, F minimum is equal to 0.